Hi, welcome to this video series on how to build an escrow accounting system for trustless transactions in the Vyper programming language. My name is Ayuba Ojonugwamu-Azu. I'm a software developer and a blockchain engineer from Nigeria, and I'm also a blockchain instructor and a software development tutor. So if you have been visiting the education ecosystem for some time now, you would have watched a whole lot of tutorials that I've made on the blockchain space and the .NET programming language. I've been in the software industry for about 10 years now, and I've developed softwares for different organizations, including the public and the private sector in Nigeria, Africa. And I've worked remotely with some organizations in the US and in Japan. I've created some, been part of the team that created some amazing applications. Now, in the education ecosystem here, I've been tutoring and mentoring students on how to create real-life projects, more especially in the blockchain space and the .NET programming language. So in this video tutorial here on how to build an escrow accounting system for trustless transaction in Vyper, it's going to be a blockchain the app that we are going to create at the end of the day. And we should be able to sell an item in a decentralized manner, where the buyer and the seller don't really need to trust each other, rather they trust the system. So, and the system is going to be a smart contract that we're going to create. So where the buyer and the seller can send in an amount into the smart contract that will act as an escrow, and until the purchase is made and the item is received, before the funds be remitted back to the appropriate parties that are involved in the sale. So that's what we're going to build in this video tutorial, and I hope you enjoy it. Thank you. Hi, welcome to session 1 on this video series on how to build an escrow accounting system for trustless transactions using the Vyper programming language. My name one more time is Ayuba Ojonugwamu-Azu. Session 1 here, we are going to look at the overview of our escrow accounting system. We're going to discuss the Vyper programming language, the Remix IDE, and of course MetaMask. So the best way we can know about the Vyper programming language is to go to the read the docs. So you go to www.vyper.readthedocs.io, and you will get to this first page here. So now, as out of the time of shooting this video, the Vyper programming language is still in its development stage. So a whole lot of tools have not been built yet to accommodate this programming language. But it's a very beautiful programming language. It's very easy to use, very scalable. And if you're coming from the Python, if your background is a Python programming language, then Vyper will be very easy for you to understand. But if you're coming from the C style programming language like C#, C++, and the rest, then you just have to adjust a little to understand the Vyper programming language. But nonetheless, Vyper programming language is very easy to understand. So if you come to read the docs, there are a whole lot of things you can read about the Vyper programming language, And you can see the first thing they said here is don't panic if the installation fails. So Vyper is still under development and undergoes constant changes, just like I said. But in our application here, we are going to make sure that we solve any error that we encounter on the way, and we make sure that we have our system up and running. So the Vyper programming language, like any other programming language out there, has its own rules and regulation, like in uppercase and lowercase are not the same. And then okay, I just clicked types. Okay, good. And then it has its own different types, you know, just like how we have in Solidity. If you have been programming in Solidity before, then I don't think you're going to find Vyper programming language difficult to learn. So now it has its types. It has built-in functions that we can call, like if you want to send some ether, you want to do some calculations, you can see we have built-in functions like flow. Vyper, you can see Vyper provides a collection of built-in function available in the global namespace of our contract. Like we have function that rounds a decimal to the nearest integer, which is this, the floor function. We have the ceiling function that rounds a decimal up to the nearest integer. Then we have the convert function, and this is how the syntax is: the value and the type convert a variable or literal from one type to the other. We have the clear function. We have the asway value. The asway value takes an amount of ether currency specified by a number and a unit and returns the integer of weight equivalence. So you provide an ether value and then you get the weight value of that amount. So you can see there are different built-in functions here that you can study. Then of course we also have low-level built-in functions like send, to send ether from one address to the other. So Vyper contains a set of built-in functions which execute opcodes such as send or self-destruct. Now the self-destruct function terminates or destroy the contract entirely. So, and we're going to use this. We're going to use these two low-level functions, the send and the self-destruct, in this video series that we're creating. Then we also have the raise function that raises an exception whenever an error occurs. Then we have an assert function that's almost like an if else, you know, so but the assert is usually better to call. So specify a condition. This method behavior is equivalent to if not condition, so raise reason, just like I said, like the if else statement. So, and the only difference is the only difference in behavior is that the assert can be called without a reason string, while raise requires one. Okay, yeah. So these are built-in low-level functions that we are still going to use. And then if you go to types, we have different types: value types, reference types, and in the value types we have boolean values, integer, unsigned integer, decimals, addresses, where we can store our addresses like our Ethereum addresses. Unit types, then we have the byte array types. We have the 32-bit wide byte array and fixed size byte array. Then we also have the fixed strings. So we're going to touch on this, any one of these, whenever the case, however the case may be, in our course of designing this application. So this is about the Vyper programming language. And actually, if you want to program with the Vyper programming language, you can install it. If you're running the Ubuntu operating system, then how to install it is here. You can follow this instruction here. And if you're running Windows like me, or if you're running Macs, you can install it here. If you're running Windows like me, I think you will have to do some extra installations before you're able to install it on your Windows machine. But don't worry, we're not going to install Vyper programming language. We are going to use the online tools that are available to create our smart contract at the end of the day. But the online tools is not really recommended for high of a production of application that will go live for production. So the online tools are not really reliable that much, but for the sake of this video tutorial, we are going to use the online tools. And the online tool we're going to use is going to be Remix, the Remix tool. So you go to remix.ethereum.org, and then you'll be you first of all have this page here. So you can see there are different environments. We have Solidity and Vyper, and if you come here, featured plugins, you can click here to see all plugins. In case you're just coming in new, you can click here to see all plugins, and then you can activate or deactivate them. In my opinion, I think you can just activate all so that you can play around them. So just activate all the buttons so you can play around them. So well, I have them activated here, so you can see these are the different plugins that I have here. Now here is my compiler, the Vyper compiler, and we're going to use a remote compiler to compile our smart contract. Then the third requirement is the Remix IDE, the MetaMask. Now, what is MetaMask? MetaMask is actually a bridge between your web of today and your web of tomorrow. So it's actually a bridge between Web 2.0 to Web 3.0. And you go to metamask.io to get to read about MetaMask. It's a very I can't think of a blockchain developer developing web apps, decentralized web apps, without using MetaMask. You know, MetaMask makes development very, very easy for you. So it's also a crypto wallet and a gateway to blockchain apps, just like how it's written here. So to download and install MetaMask is easy. Just go right ahead and hit the download button, and make sure you're running on either Google Chrome, the Brave browser, or Firefox. As at the time of shooting this video, MetaMask does not work with Internet Explorer. So just make sure you download that and have it as an extension to your Google Chrome or Brave browser. So I have MetaMask here, and then once you have MetaMask, make sure that you save your seed phrase, you write it somewhere down and keep it safe. And for the sake of this video tutorial, we're going to use a Ropsten network, and then we are going to use a Ether. We're going to use a faucet Ether, so it's not going to be real Ether. So you can see there are different networks here. We have the main network, which connects to the main Ethereum network, but for test purposes, we can use the Ropsten network, the Coven network, the Rinkaby network, or GoLE networks. But we're going to use the Ropsten network here because it's just easy. So you go to, if you don't have Ether here on your Ropsten network, you can request for it by going to faucet.ropsten.com, I think so. Let's go. You want to deposit, okay, good. So you just click on deposit like I did, and then get Ether from faucet on the Ropsten. So you just click on this button, and then it takes you to faucet.metamask.io, and then you get some test Ether here. So request, once you're here, you can request for the Ether by clicking this. So, and then the Ether will be sent to your address. So let's see. So it would like to connect to your account. Yes, let's click on connect. So you can see I have 5 Ether here, so I can request for 10 more Ether or 100 Ether, you know, just like let's request for 10 Ether and see. Oh, I think I was sending ether rather instead of requesting. I was sending ether. So you request for 1 ether, sorry, by clicking this, and then we should have and you can click this button as many times as you want to get more ether. So if we just wait a little, the transactions will get submitted to the blockchain, get mined, and we should have some faucet ether on our account that we can use. So if I click on that, I can wait later until I get the result. So now that's how you request for ether. So at the end of the day, we're going to develop an application, and then, like I said, it's going to be an application that we can store ether on an escrow account, and until the transaction is made, until the sale is completed, then the beneficiary or the seller of the item gets his ether, and the buyer also gets the ether that he's deposited into the escrow bag. So that's what we are going to do. So stay on with me onto the next tutorial, onto the next session, where we look at the application we're developing and start coding the application. Thank you. Hi, welcome to session 2 on this video series on how to create an escrow accounting system for trustless transactions using the Vyper programming language. My name is Ayuba Ojanugwamo Azu. In session 2 here, we're going to look at our DApp and then create our DApp user interface. Now, here is our DApp that we are going to create, escrow accounting system. You can see the app is saying I'm logged in as the seller, and then this is the item we want to sell. We want to sell this nice, beautiful Mercedes GL 550 2020 model, and we're selling it for 1 ether. So now what we're going to build here is how the escrow accounting system is going to work. Now, the seller of this item, which is the currently logged in account that created this smart contract, will first of all make a safe deposit. So by clicking this button, the seller of this item will make a safe deposit of the value of this item he wants to sell. Now, this Mercedes-Benz is sold for 1 ether, and I hope one day in future we are going to buy a Mercedes for 1 ether. So he will make a deposit of the 1 ether into this smart contract address here. So he will make a deposit, a safe deposit of 1 ether into the smart contract address. So that means the smart contract will now have 1 ether as stored in its escrow, as stored in its so the smart contract will have 1 ether as it is currently. If you copy this and you go to Etherscan, let's go to robston.etherscan.io. So if we view the contract, we can see that the contract has a balance of 0 ether. Oh, this is an old contract. Okay, let me use this contract. I just deployed a new contract, so let me use that. That is an old contract, so let me change the contract address to this. So if you come here and enter this contract address, which is different from this, good. You see, I just created this contract 5 minutes ago, and it has a balance of 0 ether. So it means the seller of this item has not made a safe deposit yet. So this contract requires the seller to make a safe deposit of the price of what he wants to sell into the smart contract address. Then a buyer that is interested in buying this item, you can see we have it here, no buyer yet. So the buyer would express interest in buying this item by also sending this value, twice of this value. Actually, how we're going to do it is the seller will send in twice of this value. So he's going to send in 2 ether to the smart contract address, just to keep the item safe. So at that stage, the contract will have 2 ether. Then the buyer that is interested in buying this item will also send in 2 ether to the smart contract address. So at the end of the day, the smart contract will have 4 ether. Then once the buyer in his own interface has received the item, once the item has been sold and he has received the item, the buyer will click accept that he has received the item, and then the smart contract will automatically refund back 3 ether now to the seller, because first of all he has made a deposit of 2 ether plus the 1 ether he's selling this item. So 3 ether will be refunded back to the seller and 1 ether will be refunded back to the buyer as the amount he kept in the escrow account. So that's just the simple escrow accounting system we're going to build. So let's demonstrate it and then you get to understand what I'm saying. So first of all, I'm logged in as the seller of this item, so I'll click to make safe deposit. But first of all, let me check that the safe deposit should carry 2 ether. So I'll change this. Don't worry, I'll show you all these codes and what it means. So post safe deposit of 2 ether. I'm going to post safe deposit of 2 ether here too. Let's purchase. Good. So I can refresh this. Good. So the seller of this item now is going to make a safe deposit of 2 ether. So he clicks on that button. So we wait for MetaMask to pop up. Good. So we want to send 2 ether now. The item is sold for 1 ether, but we're sending in 2 ether. So let me add a gas fee. Let's add this for faster transaction. And then we click confirm. So 2 ether will now be saved in this smart contract address as an escrow amount. So we wait for that amount to be received, and then we check our contract state, and you can see at this point no buyer yet. So we're going to see how we're going to interact with that. So wait for the transaction. Good. So the transaction 2 ether has been sent now to the smart contract. Now if you still refresh this, nothing happens. The contract state is still the same here based on the information we're displaying. But if you come to the contract address which we've picked, you check that on Etherscan, you can see 2 ether has been sent. Now this amount is escrowed here. Now nobody can withdraw this amount until either, the way we're going to design the contract, until either the seller of the item decide that he doesn't want to sell the item again, or a buyer has purchased and has received this item. So okay, now let's express interest in buying this Mercedes-Benz. Now I'm going to change my account. So I'm going to use another account. So let's say this account, for instance. And this account is not the seller of this item. So if I come here and refresh this, you can see this has changed to purchase this item, and you can see confirm receipt as buyer, because now I'm logged in as a different account that is not the seller of this item. So I want to purchase this item. 2 Ether will also be deposited into the smart contract address, making it 4 Ether. So let's click on that. Good, so we can add the gas fee. Let's select this for faster transaction. Let's click confirm. Like I said, make sure you're on the Robston network so you won't spend your money using Ether. Okay, now we have sent that. So let's watch the contract and make sure that the money has been sent. Okay, good. So transaction confirmed. Now if we refresh this page, the contract state will change to, and then we'll have the address that is interested in buying this item. So, and you can see, so we have this address now interested in buying this item. Now if you come here and refresh the page, you will see that the contract now has 4 Ether deposited on it. So you can see the contract now has 4 Ether deposited on it. So the final thing that is going to happen, the final event, will be for the buyer now to confirm receipt, to confirm that he has received this item, because the sale has been made. He has made purchase of this item, so it's for him to confirm that this item has been received. And if this item, this car, this beautiful car, has been received by the buyer, he clicks on this button, and what will happen is 3 Ether will be refunded back to the seller, which is this person, because he has deposited 2 Ether. So 3 Ether will be refunded back to him, and 1 Ether will be refunded back to the buyer, and then the contract will be destroyed. Just like I said, I'm going to introduce you to the self-destruct when we're looking at the Vyper programming language. So you can see that. So, and if you get to see the balance of the accounts, let's get to see the balance and see what we have. So here we have 24 Ether for the first account, and then for these we have 3 Ether. So if 3 Ether gets refunded back here, we're going to have 6 Ether at the end of the day. So okay, all right then, let's just demonstrate that. Let's assume this account is logged in. The buyer has confirmed the receipt of this item. Okay, good. So here's the buyer account, right? So he has confirmed the receipt of this item by clicking on this button here. Let's put in our gas price. How much are we willing to pay for this transaction? Select this. and then we click confirm. Okay, good. So that transaction has been confirmed. Now, if you refresh this page, the contract will be destroyed and we're not going to see this. But first of all, let's look at what we have here. You can see the balance of the contract is now 0. And then you can see contract self-destruct, we have it here. Now, if you go and look at internal transaction, you can see 1 Ether has been refunded back to the buyer, and 3 Ether has been refunded back or has been sent back to the seller of the contract. Now, this has happened internally, and the contract has self-destruct. So that is what we are able to do. And of course, if we come here and check the balance of our addresses, you will see that the balance has changed. Good. You can see 1 Ether has been added here, and 3 Ether has been added here. So the balance has changed. Now, this is how we're going to do our simple escrow accounting system. So first of all, let's design this interface now. Now, you can use any HTML text editor to do this, but I'm going to use Visual Studio for sake of simplicity. I've done this before. I'm going to do it again. So I go to new website. Then I select an empty website, so I call it safe. So I'm basically going to use my HTML, so add a new HTML page. So I call it index.html, and then I click on add. Okay, now another thing is we're going to use Bootstrap. So you go to getbootstrap.org and download the latest version, .com rather. So and we download the latest version. So the Bootstrap will help us, with our CSS and JavaScript. So you just click on the download button and then you download the Get Bootstrap. Now I've downloaded mine here and I have it in my downloads. Downloaded the 4.3 version. It's quite okay for me. So you select both the CSS and the JS file folders and you click copy, and then you import them into your project. Good. So now I'm going to pick the minified version of the Bootstrap and add that to my project. So now I'm going to create the interface quickly. So div class row, and then that picture of Mercedes, I actually got that. You can Google that and just add that picture. So div class MD7 text center P3. This is just give space up, and then we see escrow accounting system, right? Escrow accounting system, and then we're going to display the login info of the accounts that is logged in. So we just call that login info. P3 give it an ID, login info. Good. Then now that I'm done with that, so we do this again. Div class md3, and then no, div class p3. Let's look at the interface again. Okay, we're here, so we want to display this. So div class, this should be p3, and then we say sale of IV sale of, so we're going to display the item we're selling. We're going to display the item name, so we can make it bold. I call this item name. Sale of item name for item price. So we're going to have that, and then put a break just like I did here, and then we'll drop our image. So I'm going to create a folder. Create a folder called images. Oh, not in my CSS file, rather. Let's create a folder on my root directory called images, and then I'm going to add the image of the item. Where do I have my Mercedes image? I think I should have it in my pictures. Do I have it there? Let's check here. Flashback movies. Okay, good. So I have my image here. So I pick this, Mercedes-Benz, and then I add it here. So I have my image there now, and I can just drop my image path, and then I can give it a width of or height of 350. Good. Let's refresh this and see. Let's run these and see. Okay, escrow accounts. Okay, we're still working on it. Okay, this should be in here, so I can have it on one side. Good. So escrow accounting system, we're going to display a sale of this item name for the item price, and then so we're going to put some button. If the login account is the seller, we're going to display a particular kind of button, but if it's the buyer, we're going to display another information. So let's drop a button here. The first one we'll call it we'll call that one make purchase, or purchase this item. PTN info. Okay, purchase this item if it's the buyer, but if it's the seller, we can say make safe deposit. So we can copy this. So we'll say make safe deposit. Okay, good. But we're going to make both of them hidden, and then so we're going to make both of them hidden. Until the appropriate account is detected, the appropriate Ethereum address is detected. So now let's code the contract state area. Heavy class MD5. Let's put P3. And then we say H3. Contact center. So we can name this contract state. So P2. Good, so we're going to display our contract state here. Now the first one we have based on we have contract address, seller name, seller address, price in Ether, and then the buyer. So contract address is the first one, right? So we can put these in our table, script table. Style it, we'll say the width is 100%, or you can use this. I think we'll have that in a Bootstrap. Responsive table responsive. Good. So we can have that, and then we can just say T body. We're not going to use any T head. So the first one will say contract address, right? Contract address. So here we'll write the contract address here. Let's say 0 blah 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 blah, something like this. Then our seller name, so I can copy this. Seller name, seller address, price in ETH. Seller name, so I can just say ID, C seller name, that's contract seller name. And seller address, so you can say IDC seller address. Then our price in ETH, that's price in Ether. C price. I'll see item price, and then buyer. I say buyer address too. See buyer. That's a fresh days and see. Okay, I think I still need to style this. Give it a width of 100%. Okay, and .250 pixel. See this. Okay, good. So I think that should be okay like that. So we can just drop these here. So now the last button will be to confirm the receipt of this item if you're logged in as a seller, as the buyer rather. So TD column span should be 2, and then also text center. So we can drop our button here. You can say confirm receipt. Confirm receipt as buyer. And BTN info. So let's refresh this. Okay, good. Now I can just, let's see, P3, just give a space. All right, and we're still going to make this hidden too. I think I need to give a space here too, just to make it, you know, say P2, just to give it nice. Just do this to give a space and make it look nice. Good, so it's better this way. So now we have our interface, and in the next session we're going to create the smart contract rather, and once we're back to the interface again, we are going to arrange everything to fit into our smart contract on how we can interact with it. So thank you for watching. Hi, welcome to session 3 on this video series on how to build an escrow accounting system for trustless transaction using the Vyper programming language. My name is Ayuba Ojonogwamo Azu. In session 3 here, we are going to create our escrow accounting smart contract in the Vyper programming language, and we're going to do this on Remix. So like I said in the beginning, Remix is a tool where we can use to create different smart contracts, the Solidity smart contract and the Vyper smart contract. Now you can see I have different smart contracts I've created, and you can watch all these video tutorials here in education ecosystem /UPZ this me here, so you can just go to my projects. So education ecosystem /ubz/projects, and then you can search for me ubz, and you'll see a whole lot of my video tutorials that I did. Now we are going to create our smart contract using the Vyper programming language, and we're going to call it escrow accounting. So if you have your interface here up and ready, the first thing you need to do is you go to create a new file, and then you give it a name. So we'll say escrow accounts. Now Vyper is .vy, while Solidity is .sol. So you go right ahead and hit the OK button. So our contract is going to have first of all, we're going to have a constructor that will initialize the contract, where we'll have the item name, the seller name, the seller address, and then the value of the item, and then whether the contract is still open. So we're going to have that, and then that will be the constructor. Then we're going to have a function called post save deposits, where only the seller of the item will be able to post twice the value of what he is selling. Then we're going to have another function called abort, where only the seller can actually destroy the contract, just terminate the contract and receive his ether back, the ether that he has posted using the post save deposit smart contract function. Sorry. Then we're going to have another function called purchase, where the buyer of the item can purchase the item, and then we're going to have the last function called received, where the buyer can call that function to execute when he has received the item. So let's quickly get started and see what we're going to do. So the first one, we say declare some variables. Declare some variables, right? So we start with item name. Now in Vyper, you actually start with the variable name before the variable type. So that's how we declare that. So we start with item name. We want to know the item we're selling, so we use public and string. So just 32 bits of string that we want. So item name and item value. Item value, this should be the way value of what we want to sell. So public way value. Then of course the seller address. Seller address. So public address. Now one very nice feature of the Vyper programming language is if you declare your variables like this, you've actually automatically set a getter and a set of function for it. So that's how it's going to be. Then that's seller name, then seller name, we have seller address now, so seller name, so public string 32. Then we're going to check if the contract is still open, so we look at the we'll declare this boolean variable called unlocked. So public boolean, and then we check if the contract has ended. If the sale has ended, rather. Okay, so now we have these now, and to compile these is very easy. You go to the compiler, the Solidity compiler, click on remote compiler, and you can see you need to read this. It's really important not to use a remote compiler for production environments. Please only use it for testing purposes, and prefer to use a local compiler for production environments. So we're going to use the remote compiler. So you click on this, and then you watch how it compiles here. So you can see we've compiled successfully, no error. Now let's initialize the contract by creating a constructor. So to create that is very easy. We just do this. It's public def. Now you do underscore twice and then init underscore twice. So we say item name, string 32, right? So we're passing these parameters in our constructor. Item value, so way value, and then seller name underscore seller name string 32. Right, so and then you put this after that. Okay, so self.seller name or .item name, no matter how you want to put it, start with item name, should be this item name. And using self, it's referencing what we declared here in our global variables. So seller name, get the seller name, then the seller address. Seller address should be the accounts that is deploying the smart contracts. That's self.item value. So it should be the value of the item that we're initializing. And then self.unlocked should be true. The contract is still open, so it should be true. And then we can compile this. It's usually good to compile every stage to make sure that your smart contract is free from errors. Okay, good. So now let's create a payable function. A payable function is a function that receives ether when ether is being sent to the smart contract. Calling that function what should happen. So let's create a payable function. So public, and use the keyword payable. So let's call it posts save deposits. And then good, I introduce you to the assets. I introduce you to assets in the built-in functions. I introduce you to assets here. Low-level built-in functions. Good. So I introduce it this. So we're going to use this now. Assets the specified condition. So we're just going to check the conditions now. Sorry. Here. Good. So we're going to check whether the person posting this is actually the seller. So we're going to make sure that message.sender is actually self.seller address. So it's actually the seller address that is doing this. And then we're going to put in twice the value. So we're going to check this. Set that value. Now here is how you get the ether that has been sent into a smart contract. It's using message.value. So it's using message.value. That's how you know the ether that has been sent into a smart contract. So we do this. And then we say self with item value. should not be dot value divided by 2. So we have this. Good. This is to post safe deposit. So let's refresh this. Let's compile this too. Okay, we're having an error. What could be the error? Now, unlike Solidity, where you get to see the error immediately, Vyper is still under development. Okay, assert message.value 2. I believe that's where the error should come from. Okay, payable, sorry, spelled this wrongly, payable. Okay, good. Now the next function, we're going to, the owner of the contract, which is the seller, can actually abort this smart contract. So let's code that. So public abort, we call the function abort, and then we'll make sure that this contract is not unlocked, is not locked, sorry. So assert that's unlocked, it's true. Then assert that message dot sender, person calling this contract is the seller address. And then if that is okay, then we self-destruct. So we're going to call the self-destruct built-in function. So self-destruct, so that's that, and it's going to be the seller address, right? So we can test these two and make sure it compiles. So good. And the next function will be a payable function to purchase the item. So we're going to create that. So it's a public payable. Why am I spelling it wrongly? Payable. Good. And then we'll call it purchase. So def purchase. And then we check that the contract is still open. So this is off. Assets that's off. So you can see we're using the assets very well. So that's unlocked. Then assert message.value should be twice now. So you're sending in twice the value, just like how I demonstrated. So dot item value, right? So you're sending in twice the item value, which will be refunded after you've received the item. So should be message that sender. So the buyer should not be the account that is sending these, and then self unlocked, that's unlocked now should be set to false. So that means the contract is locked at this stage. Good. So that means you can call the contract again. You can call this purchase again because the item has been purchased. So now let's create the last function, received. So public so we'll call it received. That's you've received the item. So we check that, of course, contract assert not self that's unlocked. check that the contract is not locked. We check that the contract is locked rather. Assert. So message.sender should be the buyer. So only the buyer that can call this. Did I declare the buyer up? Let's see. I didn't declare that, so I need to declare that the buyer. So I can put that here. So we can say buyer address. Let's use buyer address. Public address. Good. So here should be buyer address, and then here should be buyer address. Good. So we now assert so not so that's ended. So now after receiving this, so we send back so that buyer send to the buyer address the item value, because if you can remember we posted twice this value here. Bring this like this, so we return the item value. And then we call the self-destruct. So we call this seller address. Now let's compile this finally and see. Okay, where is this problem coming from? Where is this coming from? Let's check from here again. Payable, right? Let's just comment this out all, and so let's compile. Okay, public payable purchase these. Let me do this. The Vyper programming language can sometimes be tricky, so I'm just trying to see where okay, good. So you can see assert here, so I believe that should be where the error is coming from. Okay, well, we'll fix that. public at payable or they've purchased. Just go back to all the last changes I made. Just all the last changes I made. Oh, this is strange. So where are we having the problem? Self-destruct, is it here? I guess up to this point we had our contracts going fine, so this mistake should be from somewhere, because up to this point we had our contracts compiling fine. Yeah, I can remember up to this point we had our contract compiling fine. So what could be this error that we're having now? See it from my internet. Now this is strange. Okay, we shall detect the problem. Now we're having all this because the Vyper is still in its development stage, so you know, you can see is it telling me that this is the issue? That is not the issue. So well, I believe something is wrong. Maybe my no, but this is supposed to compile. Strange. This is weird. So what am I doing wrong? Let me see. When I'm using local compiler or using the remote compiler. Can I refresh this page again? The changes you made may not be saved now. I believe this should be from the compiler because these codes are actually okay. These codes are actually okay. So now this is not possible. I will detect what the problem is, and then probably in the next video we'll discuss it. But as it is, it could be the compiler, so I'm going to refresh the compiler. Just copy these whole codes, refresh the compiler in case I lose these changes I've made. And then of course we need the buyer address that we added here. Public, payable, post saved deposit, right? Okay, remove this. Received good. Let's try and compile it one more time again. And funny enough, it's compiled. So, well, just like I said in the beginning, the compilation, the Vyper is still in development stage, so probably that's why we had this. Anyway, we have our smart contract now created. First of all, we initialize the smart contract. We have these variables, and then we initialize the smart contract by passing in the item name, value, and the seller name. And then the seller can now post a safe deposit. So you can see we have this assert. Make sure that the account calling this is the seller address. And then the seller can post a safe deposit, which is twice the value of the item. And then of course the seller can abort this contract. You can destroy this contract or end or terminate this contract rather, so by calling the self-destruct built-in function, low level built-in function. Now an account can purchase this item by calling this purchase function, and once the account has purchased this item, we automatically toggle the unlock to be false. So that means the contract is currently locked. No account can send an ether to it again. And then after that, the buyer account can receive this item. So by calling this function, the buyer account has received this item, and then automatically the value of that item, because it's going to post twice the value, so the value of that item will be refunded back to the buyer, and then the contract will self-destruct. If the contract self-destruct, the value of the item and the item the value that the seller posted as safe deposit will be refunded back to the seller address. So that's just going to be the simple escrow accounting system that we're going to create. And here is the smart contract. So in the next session, we are going to interact with this through Web3 and get to see how everything is working on the interface. So thank you for watching. Hi, welcome to session 4 on this video series on how to build an escrow accounting system for trustless transactions using the Vyper programming language. My name is Ayuba Ojonigwamoazu, and in the last session, which was session 3, we were able to create our smart contract, our escrow accounting smart contract in the Vyper programming language with these functions that we have here. We have the post save deposit function, the about function, the purchase function, which is payable, just as the post save deposit, and the receive function, in which the buyer of this item will call once he has received the supposed item. So now in this session here, we are going to interact with this application via the Web3 technology. But first of all, let's compile this application and then deploy this smart contract. So we click on the compile browser, like I told you. Make sure you're compiling remotely, and then we go here and then we deploy this application. So we're going to give the item name. Now I can call this here the parameters. I can say Mercedes-Benz GL 550 2020 model. So, and the item value should be one ether. Now you have to understand that the item value was actually in way, and 18 zeros, or 1 with 18 zeros is to convert way to ether, it's 18 zeros. So we just put 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So we have 18 zeros, and that gives us 1 ether. So the seller name should be, let's say, Dusan Kolik. Good. Now let's go right ahead, and we note here is the account that is deploying this application. So just like we have here, the seller address will be the account that is deploying this application. So that's on line 15 here. So let's go right ahead and click this. So this pops up MetaMask. Good, and then we get some gas fee, so we can use this for faster transaction, and then we'll click this. So now here's the amount we're paying for gas. Now we go right ahead and click the confirm button to deploy this smart contract. So we wait while we see the smart contract being deployed. So you can see it's on pending state, and then of course you can watch the smart contracts here. So by clicking this arrow, you can see creation of, and good, it has been created. So the transaction has been confirmed, and we have our smart contract address here with all the functions that are needed. So you can see we have everything here. So now we're going to interact with these via Web3 and then get to see it. So the first thing is let's go to our Visual Studio or your favorite text editor that you're using, and then just in between the body line we can start script. Now we're using Web3 here. Stay tuned for my next video, which we're going to use Ether.js to see how we are also going to interact with smart contracts. So using Ether.js, which is actually simpler to use. So okay, now the first thing is on window unload. So function. Now we check if Web3 is defined. So if type of Web3 is undefined, then we can display an error. Now usually I just for the sake of this tutorial, I usually just declare a div up and I name it MetaMask, and that's where I just display all my errors. So here now I will just say document get element by ID MetaMask inner HTML should be you need MetaMask installed. You need MetaMask installed. Okay, good. Then after that, the next will be we'll create a function called retrieve values or get values to fill in these values here, to fill in these values of contrast state and all the necessary values that we're going to do. So I'm just going to call the function get values. So I'll say function get values. And then we put this inside our try and catch block. So the first thing we need to declare is our ABI. ABI stands for application binary interface, and it describes the metadata of our smart contract. So if you come here, sorry, I went to my profile. If you go to Remix, you go to Solidity, right? Good. Okay, no, sometimes I usually forget between Solidity and Vyper. Okay, we'll go to the Vyper programming language compiler. Now here's our ABI, so we click to copy the ABI. So we'll click to copy the ABI, and then we're just going to add the ABI here. So we will use the ABI throughout our okay, of course, expected catch. So catch an error. Good. So we have the ABI here, but first of all, let's just do this document that gets element by ID. So if there's an error, MetaMask should display MetaMask inner HTML. So this should display the error. Okay, so for here now we've declared our ABI. The next thing is to have our contract address. So variable contract address. We need to copy that from where we deployed the smart contract, so which is this. So you go back to your Remix and then you copy that contract address there, and then we have that. Excuse me. Now the next thing, we also declare a variable my ABI. You can also declare a variable actually without writing that variable, so without writing the var keyword. So eth.contract address, eth.contract, sorry. So ABI. Now and then we declare another variable, my function. So should be my ABI at the contract address. So this is pretty much straightforward. So now that we have this, we can start by calling our item name. So I say my function item name. Now we're calling these function here. We're calling this item here. We're calling this. We want to get the item name, the Mercedes-Benz. So we say item name. So we call that. and then we'll pass in, there's no parameter, so we'll just pass in our function, and then we check our result. So we can do this like this. So if there's an error, then of course we display the error. We say documents.get element by ID, MetaMask, inner HTML. So we'll display that error there. But else, if there's no error, which means if there's a result based on what we've defined here, then we can display the item name at the appropriate place. So now we said we want to display the item name here, so we've named it sale of, so we have the item name here. So we just go here, we say document get element by ID, item name, inner HTML should be result. Good, and that's that about that. So we can put this here like this. So now we've called the item. So let's refresh this page, index.html, that we created, which is this last one, I believe. Refresh it and see what we have. We're supposed to display it here. Okay, sorry, I just remember we didn't call that. We just declared the function, so let's call it. So we call it here on Windows load get values. So that will be called once MetaMask is detected on Windows load. So let's refresh this. Good, so you can see sale of Mercedes-Benz GL 550 2024. So we're going to put the item price now. So it's pretty much the same thing. I can just copy this whole function. The only difference is in what we're calling. So we're calling item price, I believe. What do we have here? Item value. So we're going to call item value. So it's item value. So here should be what we have here. Should be what? Item price, right? So item price. Now once we run this, we're going to this is going to show us the value in way, not ether, but we want to display the value in ether. So you can see the value is in way. So we need to convert these to ether. So, and how are we going to do that? It's very easy. So here's what we're going to do. We're just going to declare constant. We can just say constant amount, and then that should be web3 from way. So we're converting from way to ether. So from way, and what is the value? Which is result. The results that we have, and then we're converting it to ether. So it's as simple as that. So I can just come here and then change this result here to amount, and I can even go further to do this. For 1 ETH, that is 1 ether. So once we refresh this, we will see the value. So good, sale of Mercedes-Benz GL 2020 for 1 ether. Now that we have that, so let's display we will display the next thing for us is to check if the logged in account is the seller, and if he's the seller, then we will display display this button here, make save deposit. So if it's the seller, we'll toggle out that button to be true, so the seller can make a safe deposit. But if it's not a seller, then we'll display the other button, which is purchase this item to display that, because it's not a seller. So let's do that. Now we are going to check that. So so let's do that. I'm going to say my function. It's basically going to be the same thing. The only thing is it's basically going to be the same thing. Okay, let me see. I'm gonna approach this. So I'm going to call the seller address first. I'm going to call the function for the seller address. So the seller address. So let's call the seller address. I think it's a small s. So we copy this whole thing and look at, here's the function we're calling. Here's the variable once it gets seller address. So we will get the seller address and then check if the logged in account on MetaMask is the seller. So if he's the seller, then we display that button, we toggle it to true. That's the make save deposit button. But if not, we toggle it to false. So we can cancel this, and then we can cancel this. So now after calling this, I'm going to I'm going to check for this get accounts. Okay, before I do that, I think I should first of all, let me fill in this first. Let me just fill in this contract states first before we do that. Let's first of all fill in this contract state. And one thing I noticed, I need to toggle this to false first, and it's only when there is a buyer before we toggle it to true. So I can change the heading of this. Can hide this button first, and then we're going to check if we just hide that, and then we're going to check, refresh that and see. Okay, so we're going to check that. Confirm receipt as buyer. Okay, save this. Okay, good. So now maybe I should just do this first. I should just continue with the, since we've called the seller address. So we're just going to check if the logged in account, like I said, is the seller address. So we do that by saying web3.eth.get accounts get accounts. So it should be inside after we've gotten the result. So we run this. So we say function. We can write this error and then accounts. So we look at this. Put this here. So now I'm going to check for my accounts. So if accounts, if the accounts, that's the accounts that we are checking, if the accounts, the first account is the same with result, then we can toggle that button to be true. We'll have to check this make safe deposit, right? So we call this, let's give this button a name. We'll say button deposit, or let's say button post, or button save deposit, then button purchase ptn purchase, just any name. Okay, so I'll come here now. I will say documents dot get element by id, button save deposit, but hidden should be false. I think I need to test this. I'm not sure these accounts like so let's run this and see. Okay, good. So we have it correctly. Now it means the logged in account is it means we have the logged in account, so you can check that. So it means the account that is currently logged into MetaMask is the account that deployed the smart contract. So this is it. So if we change this account now, for example, if we change this to, let's say, the second account, change this to the second account and we'll refresh this, the button is not going to display. So good, it's not going to display. And okay, we need to put the information here. You are logged in as the seller of the account, just like we did in the other video. So if this is true, then we can also just put this here, login info. So we can say you're logged in as the seller of this item, documents dot get element by id. So login full inner HTML, so we can display the message: you are logged in as the seller of this item, of this item. So we have this. Go right ahead and save this. Change his account to the seller. And then refresh this. So So good, you're logged in as the seller of this item, sale of Mercedes-Benz, this for $1. So you can click on this button to make safe deposit. But first of all, let's fill this first. So for our contract address, we can just pick that from here, and then just add that here. You can just add that here. Okay, one thing, let's not forget here, we still have to do things here. So if we toggle this to false, it's better we keep this to remain as true in case we're going to toggle this to true later. So button purchase should be true. So we copy this, button purchase to be true. In fact, we say if this is this, else, so we can just else. If it's not, then we can pick this whole button here, make the save to be hidden to be true, and make the here should be purchased, sorry, purchase, here should be purchase. And this should be false. So we display it, and also we also display that is if it's not a logged in account, it's probably a buyer. So we also display this button here, receipt. So I call it button receipt, btn receipt, to also be false. So copy this here, to also be false. And then I copy the same thing, and then I make it true here, so it remains true. Good, so I think we're done with that aspect. And the next thing is like I said, we're filling in the contract state information. So the seller name, we just display the seller name. So we say C seller name. We can display the seller name by just calling that. We can just pick any of this, go below here, a function seller name, right? We don't need this, so we just change this to C seller name. C seller name should be result. Good. So can I run this again and see and make sure that everything is okay? Okay, you can see the seller of the item is Dusan Kolik, and then the seller address, that's the address that will receive the funds. So can remove these, C seller address, and then C item price in Ether, right? So C seller address, and then C item price, C seller address, and C item price. So we can just come here, pick this whole contract, the whole function. So we call the seller address, and then we just change this to seller address, and then item price. So it's the same thing. Why should I call that again since I have it here? So there is no need of calling that again. Rather, I will just call the buyer address as the last one. Buyer address. This is documents. This is documents. T. It's because we didn't get the error, that's why we didn't get to see that. So change all this to document, just so it now. Okay, good. So the last one I said is the buyer address, right? We call in the buyer address. Let me verify. Buyer address, good. So, and then we're going to say C buyer address, I believe. C buyer address. Okay, C buyer. It's not address. C buyer. So I was talking about the seller, the item value. Okay, good. So you can see the buyer is there's no currently there's no buyer yet, so we can actually display a message here, or we could just leave it here. We could just leave this value, so this means there's no buyer yet, because that's a 0 address. Now okay, let's display the price in Ether. Let's just go back to the function we called, and then I think we should just pick this. We should pick the whole of this function. This line code, and also C item price, right? That should be the good C item price. So we'll refresh this. So you can see we have our full contract details yet. So there's currently no buyer yet because it's a 0 address that we have here. Now you can decide to put some logic here too. You can decide to check that if it's a 0 address, then we display a message, no buyer yet. But if it's not a 0 address, then we can, let's do that. Let's just copy this, and then we can just come here for the last one, which is a buyer. So we can say if result is this, if it's a 0 address, then we'll just display this message, no buyer yet. No buyer yet. Else we'll display this. So we can have it this way. So let's refresh this. Good. So you can see no buyer yet. So now that we have these, this here because I saw this display. Now the next thing is we're going to code this function called make safe deposit, in which the seller of this item makes a deposit of twice the value of what he is selling, twice the value of this Mercedes-Benz. So, and then the buyer will also make a deposit of twice that value before we are able to conclude the sale of this escrow accounting system we're creating. So let's go right ahead and create that. Now let's create that function. So we call the function post deposit, post safe deposit then. So so how much are we going to post? Just 2 ether. So we're going to convert that. So web3 that's 2way. You can notice this is different from way now. So we're posting 2 ether. Then check our API, variable API. One thing is, I'm actually doing this just to show you how all this is, but you can actually declare all this variable I'm copying now. This piece of code I'm copying, you can actually declare them up and then just use them as global variables, but just for the sake of simplicity, so you get to understand what we're doing. So I paste all this because they're the same. So the next thing now is we just call the deposits function. So let's call this function here, post safe deposit. So I can just copy this function. So you can notice it's a payable function, so it means there must be we must be sending ether alongside this function. So that's why I declare the amount here that we want to send. So post deposit, and then so from web3, that's the accounts that is currently logged into MetaMask. Accounts 0, and then gas. Let's pay for this gas. Let's use 2, 3, 4, 5. I think that should be okay. We'll check that as we proceed. Then the value now should be this amount. So that is that. Then we pass in a function to check whether this is successful or there's an error. Result. Good. So we can just leave that like that without displaying anything. Good. So post deposit. Right. Good. Now let's run this and see. Let's call that function post deposits. That should be make safe deposit here. So on click of this button, let's call post deposits. So let's run this. Good. Let's click on this button. So notice we're sending in 2 ether to this smart contract address. Okay, good. So we're sending in 2 ether. I can just add some gas fee here. Here is how much I'm willing to pay for this. To make it fast. So we'll click on this. Now one thing is I can, as the contract is still pending, as the transaction is still pending, I can copy this and view this on Etherscan, robstan.etherscan.io. Here, etherscan.io. Let's view this and let's see how much ether we have, our smart contract has. You can see 0 ether and there's a transaction that's currently pending, so value of 2 ether. So let's wait for this transaction to get mined, and we see the value changes.
So we're watching this on Etherscan. You see, it is the beauty of the blockchain. Now, even if a contract is still destroyed, is self-destruct, the information is still there. The contract is still there for the whole world to see. As long as you have a contract address, you can view the public record and see everything that has ever happened in that contract. So let's wait for this to get mined and let's see what is going to happen. So you can click on this transaction hash to see everything that is going on. You can see this has been submitted a minute ago. To me, the transaction is taking quite some time, even though we paid for faster gas fees. Okay, while this is pending, let's proceed to the next. The next one is to purchase. That vehicle, and then it's in fact the same function. It's just the same function. It's just that one can be done by the seller of the contract and the other one can be done by the buyer. So it's the same thing. The buyer is sending in twice the value. So we'll just copy that deposit and drop here and say purchase. It's basically the same thing. So we'll just say purchase. And then on click events. So I said purchase. Good. Now, as an assignment, I'm going to leave you to add the self-destruct in case the seller of the item doesn't want to sell the item again. You can drop another button here called abort sale or self-destruct this contract. So you just click on that and then this contract gets destroyed and all the necessary ether value should be returned back to the owners. But to just give you a hint, here is what you're going to call. You're going to call this function abort function. So it's just as simple as that. Now I believe that transaction has been mined. So if we go back to this, we'll refresh this. So our contract has 2 ether now as its balance. So we have that, right? So let's just quickly create the last button, which is this, where the buyer has received the item. So let's just quickly create that function. So it's almost pretty much the same thing, but just a few. So I'm just going to copy this too. I'm just going to copy this. Paste this here and I call this received. Received, it means, so now we don't need this amount, so I can leave this out, and we don't need this value here, so I can leave this out too. So, and then okay, for purchase, sorry, I need to change this to purchase. Let's change this to purchase. I believe that's the name we have here. Purchase, and we received. So, and then you change this to received. Received dot send transaction, because you're calling a function that is not a payable function. So good, and this is okay. So we can now call these here on this button. So on click of this button, we can now call received. So we have this. So I think we're almost concluding this video. So if you refresh this, you can see there's no buyer yet, but our contract state has been changed. We have 2 ethers locked in this contract, just to prove that we are the seller of this item. So we've locked in 2 ether, twice the value of this Mercedes-Benz has been locked there. Now let's assume this address has changed. The next address wants to buy this item. So we'll click, let's change the account. Let's assume the second address wants to purchase that item. So we can refresh this. Good. So you can see no buyer yet, and currently this is not a seller of this item. So he's going to purchase this item based on the functions we've created. We click on this, purchase this item. So this will call the purchase function, and 2 ether will be sent to the smart contract by this address that wants to purchase this item. So our contract will now have 4 ether. So let's choose this for faster transaction, and then click confirm. So we can watch these here. I think we need to refresh. Okay, wow, that's nice. This has gone fast. So if we refresh this, you can see we have 4 ether now, and if we refresh our system, buyer address will change. So you can see this is the buyer interested in buying this. So let's assume now, after sending in 2 ether, the seller of this item, that's Dusan Kolik, got to see this item, got to receive this funds, or got to see this funds, sorry, deposited here in the smart contract. Now if you call this the second time, most definitely you should know that we're going to have an error if you click purchase this item, or if another different address should attempt to purchase this item that's already has been locked, we're going to have an error. But as an assignment, I'll also like you to probably display an error, or display here on the screen, here, that this item has been purchased. Now let me give you a hint on what you can do. Here's what you do. You will call these unlocked. So you're going to call this, variable. So if it's true, it means the sale is still open. If it's false, then it means the sale has closed. So just call that, and then just add the logic here. Okay, so that's that about that. Now the buyer now wants to confirm that he has received this Mercedes-Benz in his garage. So he comes back to the smart contract. So on clicking confirm received as a buyer, 3 ether will be sent back to this seller here, Dusan Kolik, and then 1 ether will be sent back to the buyer's address, and then the contract will self-destruct according to the rules that we have here. In received. So you can see, first of all, we checked that the sale is still the sale has been locked, and then we check that the person clicking received is not the sender. So then we check that it's the buyer and it's not the sender, and then we check that the seller of the contract has not ended the sale. Then we do this, we call the send, and the item value, which is 1 ether, will be sent back to the buyer, and then the contract will self-destruct. So that's just what that's what's going to happen in this button here. So let's click on it. Okay, good. Let's pay for some gas. Sorry. Let's click confirm.
So we can watch the state of the contract. Okay, all right then. So that has been received. I can refresh this again. You can see the balance is now 0 ether, and it means that a whole lot has happened in the background. So if we come here to refresh this, you can see. So you can see we have a whole lot of errors here because the contract has self-destruct, and the ethers has been sent back to the respective addresses. So good. So you can see we have an internal transaction here that you can look, and you can see 3 ether has been sent back to the seller of the contract, 1 ether to the buyer, and then the contract has self-destruct here, so you can get to see that. But that doesn't mean that the history is still not in the blockchain. So this history is here forever for anybody to view. So okay, all right, now that's about that. We've concluded an escrow accounting system. A safe remote purchase has been done, where both the buyer and the seller need not trust each other, but rather to trust this smart contract here that we created in this address. So thank you for watching. Hi, welcome to the concluding parts on this video series on how to build an escrow accounting system for trustless transactions in the Vyper programming language. My name is Ayuba Ojonogwamo Azu. Now, what we learned so far was, first of all, we started with the overview of the escrow accounting system. We looked at the Vyper programming language as an alternative to Solidity, and then we looked at the syntax of the Vyper programming language, in which I said if you're coming from the Python programming language, then Vyper programming language will be very easy to understand. But if you're coming from the C# programming language like C#, C++, and the rest, JavaScript, then you're just going to find some few differences here and there. But nonetheless, the Vyper programming language is easy to understand and easy to learn. And this tutorial here aims to teach you the syntax of the programming language and the logic of how you can use that programming language to create your DApps and smart contracts. Now we look at the Remix IDE as an online tool that you can use to write smart contracts, but not really recommended for production ready smart contracts, more especially if you're using the Vyper programming language, because the Vyper programming language is still in developmental stage, and you know, there are still some few errors here and there. Then we looked at MetaMask as a bridge between your smart contract and your web page, your HTML page. So okay, then we went to session 2 where we created our app, and then we created an interface that looks like this. At the end of the day, we're selling this Mercedes-Benz for 1 ether, in which I pray one day we'll buy Mercedes-Benz for 1 ether. I know we're heading there. So then we created our escrow accounting smart contracts using the Remix IDE, and then we had these functions. First of all, we have our variables that we declared. Then we initialize the smart contract by passing in the item name, the value, and the seller name. So the item name here in this case is the Mercedes-Benz GL550 2020 model. Then we created this payable smart function where the seller address, that's the seller of this item, has to make a deposit of twice the value of what he's selling. Then we also have this that we didn't call, but I left as an assignment that you can use. You can call this abort function to untimely stop the sale of this item. Let's say you've changed your mind, you're the seller of this item and you've changed your mind, so you can call this function. Then we also have this payable function called purchase, where the non-seller, that's any address that is not the seller, can purchase this item. And once this this function has been called, then the item, the sale will be locked, so that any other person that sent ether calling this function
won't be able to won't be able to send ether to the smart contract, and his ether will not be lost. Then we have the received, the confirm received item, where the buyer, after the sale has been concluded, can click confirm receipt and self-destruct this contract at the end of the day. So from there, of course, we interacted with our smart contracts using the Web3 technology, and then which we looked at the different tricks and techniques we can use to create these. So if you've watched this far, congratulations on writing smart contracts in the Vyper programming language. Once again, my name is Ayuba Ojanugwa Azu. Thank you for watching.